Okay, we're going to start out today talking about a problem with the T-Rex. Okay, we have a hungry T-Rex looking for dinosaurs to eat. In his search, he throws a boulder with a mass of 1,400 kilograms. The boulder rolls at an acceleration of 1.2 meters per second squared. How much force did the T-Rex use? Okay, when I'm solving these problems, the first thing we do is we try to figure out what the problem says. So I'm going to put squares around the important information. The first important piece of information is 1,400 kilograms. Okay, that first 1,400 kilograms is our force, mass, or acceleration. Kilograms tells me mass, and it also says a mass of. So there's lots of context in the question that helps me here. I'm going to write 1,400 kg. Okay, kg is the same thing as kilograms. Next important piece of information. So the boulder rolls at an acceleration of 1.2 meters per second squared. Okay. Again, that says acceleration. I'm going to write that down as acceleration 1.2 meters per second squared. I can use my writing tool or I can use my text tool, either one. When I'm just writing down words, I find it easier to text, but if I'm solving problems, I like to use my writing tool. Now, what are we calculating here? Well, there's other important information in the text. It says how much. How is a word that's going to be a question word, so it's telling me I'm looking for what's my question, and the word I see that's important here is force. So my question is force, and in the force I'm going to write question mark. What are we calculating? We're calculating force. And the reason this box is here is to make sure that we are double checking we don't have something written in the wrong box, because force is what we're solving for, and if our force doesn't have a question mark here, we probably have something put in the wrong place. Now we're going to solve the problem. We start by figuring out which formula we want to use, and then we can do that by looking for the formula that says force equals, or in this case F equals, because F is standing for force here. And there's only one equation that says force by itself and equals, and that's F equals m times a. So I circle that, and now I'm going to go and show my work. So when I'm showing my work, I like to use the pencil tool so I can just write it out, because sometimes I'm multiplying, sometimes I'm dividing. And so F equals 1,400 kg, which is my mass, right? So I'm just plugging my mass from the equation, or from the problem into the equation, times my acceleration, which from the question was 1.2 meters per second squared. Okay, so then I plug that into my trusty calculator. I get 1,400 times 1.2, and that is 1,680. Okay, so in my answer, 1,680. Now, that's my answer, but it's not complete. I need my answer with my units. So my units for force. What are the units for force? In our class, we will always use newtons. Okay. So units for force, newtons. Or if you want to write it the short way, you could write 1,680 N, capital N for newtons. Great. So that's one example. Let's check out another one where we're not solving for force, but solving for instead something different. In this scenario, we have an unsuspecting Stormtrooper who comes to the realization he's in the wrong spot at the wrong time.
Man, these helmets are really uncomfortable. Wait, what's that? Huh. Hey, halt! Stop! No, stop! No.
As a result, he's hit by a fire truck. If the fire truck delivers a force of 970 newtons and the Stormtrooper has a mass of 85 kilograms, what acceleration did this create? Okay, so very procedurally, I'm going to start out the same way. I'm going to put boxes around the numbers that are special. Okay, here we see 970. That's not all. We see also over here newtons. Okay, it's not on the same line, but I still want to put a box around it because that unit is important. It helps me know what I'm talking about. Okay, so what is that I'm talking about? 970 newtons. Is that force, mass, or acceleration? Okay, again, looking back to the words, there's a context here. It says force of, so force is 970 N. Capital N, same thing as newtons. We can use that to make our lives a little easier. Next thing we're going to do is going to put a box around the next piece of important information, 85 kilograms. Okay, 85 kilograms, is that my mass or my acceleration? Okay, well, look at the question. It says mass of blank. So, guess what? It's our mass, 85 kg for kilograms. Okay, another way of writing kilograms. And then the last thing we know is, here's our what. What is our question word, cluing us into that we're finding a question mark next to acceleration. So by acceleration, I'm going to write my question mark. Don't know yet. We don't know yet. We're going to find. So what are we calculating? My question mark is by acceleration. The question word in the sentence is talking about acceleration. So we are trying to find, that's right, acceleration. Oops. All right, now the next thing we do is we circle which formula we want. Again, we want a formula that says what we're solving for equals, and it's by itself. So there's only one equation that has acceleration equals, or in this case, A equals by itself. And that's this top left one where it says A equals F divided by M. So we are going to write our information in. So A, or acceleration, is going to be equal to my force divided by my mass. My force, 970 newtons, divided by 85 kilograms. That's my mass. Okay, these numbers again, I'm putting them where I'm putting them because force goes on the top, mass goes on the bottom. And I'm getting my force number from here, my mass number from here. When I write this in the calculator, okay, I've got everything in there I need. I like to write 970, then I push the divide button. This might seem easy, but sometimes people get confused of which one you divide is divided by which one. So they get the wrong answer. So when I see 97, then divide 85. So I'm going to write 970, sorry, not 97, 970 divided by 85. What do I get? 11.4. Okay, so my answer, 11.4 units. What are the units again for acceleration? Well, if I don't remember, I can always go back because the last question talked about it, and my acceleration's units were meters per second squared here. We're going to use the same units this time too, so I'm going to write down meters per second squared. Okay, so we have our answer, and it looks like our Stormtrooper got hit pretty hard because 11.4 meters per second is a pretty quick acceleration. And the video showed us that as well. Next, let's look at that Incredible Hulk. Incredible Hulk is one of his angry rampages again. In his fits of rage, he punches a dump truck with a force of 35,000 newtons.
Hulk smash!
The truck accelerates at a rate of 4.2 meters per second squared. What was the mass of the truck? Okay, so a different equation here again, but I'm going to approach it the same way. Again, starting by putting a box around the important information. The first piece of important information, or something that has a number, is 35,000 newtons. Okay. All right, let's think about my context clues. It says force of, and it also says newtons. Newtons are the units for force, and it also says force of. So this I know is going to be my force from the context of the equation. So I'm going to write next to force 35,000 capital N. Okay. Next piece of important information. Okay, number 4.2 meters per second squared. Okay. Okay, it says accelerates at a rate of. Okay, so rate of is, you might think, where's rate? I don't see that on here. But accelerates, acceleration. Okay, very similar words. This is telling me acceleration. Also, meters per second squared was our acceleration unit. So, next to acceleration, I'm writing 4.2 meters per second squared. Okay, we use a little caret with a 2 when we're writing squared in our computer, because sometimes it's a little hard to do that little superscript. So we'll just do it this way for practice sake. And the last piece of important information, I find my question word, which is what, and and it's talking about mass. What mass? So I'll put a box around mass, and that's telling me it's my question word, question mark next to mass. So what am I finding here? I'm trying to find what the mass is. That's my question word. I'm going to write that in just to make sure that I know I've got everything in the right place. I'm double checking, and I see mass. Okay, so which equation do we have that shows mass equals, or in this case, m equals by itself? And then all the other stuff is on the other side of the equation. Top right one here says m equals F divided by A, or force divided by acceleration. So if I know my force and my acceleration, I can find the mass of that object. So let's use our pencil tool and write it out. M equals F divided by A. So F is force. My force is 35,000 newtons. Divided by my acceleration. A is on the bottom. My acceleration is 4.2 meters per second squared. Okay, again, if I'm putting that in my calculator, I'm going to write 35, undo. I'm going to write 35,000, the divide button, 4.2 equals. Okay, 35,000 divided by 4.2 on my calculator, I get 8,333.3333333333. Okay, we don't need all those threes. We'll just do 8,333. Okay, 8,333. Okay, now when we were talking about mass before, what was our unit we used for mass? Okay, again, if I don't remember, I can go back to the previous problem that we did, and mass here, mass of 85 kilograms. So I can write out the word kilograms, or I can use our shortened little version of kg. So you're going to be doing some problems this week solving for the different types of parts of the equation. I hope this helped. If you have any questions, feel free to email your teacher to ask for further clarification. Have a great day.